Yeah, okay. Hi, everybody, and thanks for stopping by. I'm Wolle, and today I will be presenting the talk Data Validation at Scale, Managing Data Quality in Complex Data Pipelines. I already uploaded the slides, but you can also find the slides and additional stuff on wolle.science, just as a hint, if you're interested in what we're talking about here. So a brief introduction of myself at the beginning. I'm Wolle. I'm basically a guy from Hamburg, so I did my PhD here and research database systems, NoSQL database systems, stream processing, and everything in between. And while I was doing my PhD, literally in the office next door, the company Backend was founded. And then I actually left the university during my PhD so that I could work in that startup. And then I did my PhD on one of the core systems. And the cool thing was that I could actually do my PhD and my research and all the teaching at the University of Hamburg on topics that are really practically relevant. So we were actually in student theses and also in papers and my PhD building things that actual users were keen to get. Yeah, and this is basically the theme of my research life. So I'm trying to solve problems that actual people actually have. Even though I, again, left backend and joined the University of Oldenburg as professor of data science, I still do practical stuff. So I'm a data scientist, and I try to make the world better by analyzing data and solving real problems. And this is basically what the talk today is all about. And this is the outline. So there are three main parts here. The first one is I try to convince you that data validation actually is a thing, so it's important. You should think about it and ideally do it if you are doing stuff with data. So I talk about data science pipelines that I've seen in practice and try to explain and get across where validation is taking place there. And the idea of data validation is to improve data quality. So the next big part of the presentation here is what is data quality? So what dimensions does it have? How can you measure it? And how can you ensure it? And in that context, we'll also talk about constraints as the mechanisms or tools that you can use to ensure and enforce data quality. And then we'll get to the meat of the talk, which is blah, blah, blah at scale. So we'll talk about the challenges that you get when you actually try to implement data validation mechanisms in pipelines that have some form of scale, like much data, high throughput, very complex schemas, that kind of thing. And the running example here will be the data science pipeline that we developed at Backend. So this is basically because I built the thing and I know much about it, and I've seen the practical problems there. And I'll only touch it briefly here, but later, I think at 5 p.m., there will be a presentation by Felix, founder and CEO of Backend, who talks more about the actual data pipeline. So if you're interested in how exactly this thing works and what it does, just go to that talk as well. Yes, and this thing here is the data science pipeline, or the data real user monitoring pipeline. Basically, the core theme of the company Backend is to accelerate websites, and to actually make this efficient, we need to track performance to understand what is performance like now, and when we accelerate things, does it get better, and by how much does it get better? And so you see that on the far left there, we have the data collection part. So there's tracking information, like people would visit a website, and then the JavaScript code collects like performance timers and stuff. This is the collection, and the data that is being collected is then sent to some cloud backend for ingestion, so like MongoDB, S3, whatever. And this raw data is then being processed in such a way that you can actually write SQL queries and analyze the data, or visualize that, or so on. So there's some kind of reporting or insights component there. And as I said, there are these four phases here. And I think the most complex aspect here is the processing and storage part, because as I said, you have all kinds of reporting and insight analysis things on the far right, so the analysis, reporting, and machine learning things. And this requires you to process your data in various ways. So for example, if you want to build a dashboard on top of your data, so on top of the raw data, you may want to compute summaries like hourly counts and have some kind of like you need the traffic by time for an entire month or so. You need to optimize your storage in such a way that you can actually fire up a dashboard query when somebody visits a website and have a very quick loading visualization of all the data. So you need specific processing and storage for this kind of thing. But if you have a developer and she wants to actually try to find a problem that she had in one of her sessions, then you also need like a warehouse, for example, where you can really see all the data for the individual page loads and track down problems in individual user sessions. So this is another form of processing or data storage that you need to serve this other use case. And if you have a machine learning model, for example, because you want to predict page loads based on what people have clicked on so far, then you also, again, need to process this data in a different way and store it in another way. So these are various use cases that you have. And in all of these use cases, you need to make sure that your data is actually correct so that you, for example, have a dashboard that shows you the truth about the traffic that you had last month, or you have a good, you have actual error information when you debug a session, or you have good data that you can feed into your model to predict user behavior or find popular journeys on your website or something like that. And as you can see, this is the main goal of data validation. So you just need to make sure that the data that you have in your pipeline is good enough so that you can do stuff with it. And the things I just mentioned could be important for your business on all levels. For example, external reporting means you give out the data to customers, and then they see something that you report about their website, and they can cross-check that with their own tracking, like Google Analytics, whatever. So it needs to be correct so that you don't look like a fool when you give out the illustration of how traffic was last month. Or for internal reporting, you need to make sure that you can actually optimize your product because you have a clear view on what the problems are. And also, if you are making a decision like strategy planning, you need to have the right numbers to actually make sure that you're making the right calls. And data validation can happen on all different levels. So for example, you can start when collecting data in the browser that you try to normalize inputs and have basically data sent downstream in the same format for all different browsers. You can then make sure that you, for example, normalize inputs further when you apply pre-processing to make your storage as efficient as possible. You can apply custom business rules in the various processing steps that you have in the backend. And finally, you also get lots of complaints and bug reports. And this is also kind of validation because people typically tell you very clearly when things do not work as expected. And in the rest of the talk, I'd like to illustrate different aspects of data quality that we have encountered just to get across why it's important and challenging at the same time to make sure that your data is valid. And we're looking at 4 different dimensions of data quality here because I think they are kind of easy to understand and arguably the most important ones, but you should know that there are more. So you could, depending on the paper you read, find more dimensions. And I think just 4 is a good number, and these are quite relevant. The first one is completeness. So first, we'll ask ourselves, okay, do we have all the data that we need to do what we want to do? And in case of our example here, we want to assess whether page loads are actually fast. And when we say that, you have in your mind, maybe, at least I do, like there is one record in my database for every page load. But actually, when you do the tracking, you don't get one single database record from your browser. You actually get loads of tracking beacons with tiny bits of information. So if you have one single page load, that would be like on a timeline, the dash box here, like this is the information that you actually get from someone clicking on a website and then sending you information on how the page load went. But that means that you have to collect all these different data beacons there and actually merge them together into a single record. And obviously, you don't just have one single page load. When you have such a data pipeline, you have more of them. So there are like millions of them. And if you do all this merging here, again, Felix will tell you how we do that. You end up with a table that looks something like this. So obviously simplified, but this is the main ID. You have a timestamp when exactly the page load started. Then you have an ID, then you have the browser. You also would have information like the device type and so on, but let's just take the browser for here. Then you have performance timers that actually represent how fast the page was. In this case, it's the largest contentful pane, the LCP. And then you also have a session ID that tells you basically which page load was in the same sitting. So if they have the same ID for the session here, that means that someone clicked all these pages in a row. So this is basically the user journey then. And then you also have the URL, so the actual website that was entered. And when we're checking completeness here, we actually ask ourselves, do we have all the data or is something missing? And obviously there are things missing here. So we just have maybe missing records, so we don't really know, because if we have nothing from a page load, obviously we can't tell. But even if I don't have, do I have? Okay. Even if we have information on a page load, could be that there are some attributes missing. So, and the question is, how exactly can something like this happen? And there are many ways, but one of them is, and Sophie mentioned that in her talk right before this one, that sometimes beacons just get lost. So let's just assume we have a page load, and then the page is fully loaded, and you click to the next page. Then sometimes the last beacon, and this is basically very prone to getting lost, is the unload beacon, because this is like the last breath of your browser sending info away and then navigating to the next page. And this thing here is likely to get lost. And Eric looked into this more closely. And I think it's a very good analysis and illustrates the different challenges that you have. So what you would do if you realize, okay, this kind of data attribute here is missing very often, and it seems to be the one that is being sent with the unload beacon, you try to find out whether this is actually like a common problem or whether this was just coincident that you saw this very often. And then he found, okay, no, this seems to be like a systematic problem. The info being sent with this particular beacon often gets lost. So what he then did is try to find out when exactly this happens. So is this one specific beacon type? Maybe does this depend on the implementation, because there are different strategies how you can send info on this beacon. And then he also tried to find out for which users this is a problem. So like which browser and mobile, desktop, tablet, whatever. And this is kind of complex because there are different strategies to send unload beacons. Here you see different variants of the standardized forms. And then there's also the one that Sophie also hinted on already, which is an experimental feature that is currently on test or trial, basically in Google Chrome. Here, that's Sophie, that's her talk. And what Eric found was quite astonishing, I think. There are, crass differences in the different implementations. And what you see here is that different strategies perform kind of on the 90-80% reliability level, which is already kind of lame because it means you're losing 10 to 20% of the data beacons in a good case. But also, if you're using the before unload strategy, then you're losing your data all the time and on mobile devices, and like 3/4 of the time on desktop devices. This is bad because obviously you're lacking data, and this is also bad because it means that if you are analyzing stuff, you have data skew because desktop data is overrepresented. And this can be important to understand when you're looking at your data, because you would analyze things and say, okay, well, this value is kind of missing most of the time, but I can still use what I have left. And you need to be aware that you are not really seeing mobile data in your analysis. So just as a remark, this can be one of the problems with completeness problems in your data quality. Yeah, then Eric checked out, okay, we have problems on mobile devices with this particular strategy. How does it look when we check out the individual browsers here? And what you see there is that they kind of perform okay-ish, 80-90%. But here on Safari, there's like a very bad reliability problem for this particular strategy. So this might explain why mobile devices are so poor here. And then the idea was basically okay, but visibility change, page height, unload, and so on, they seem to work okay. Couldn't we combine those? And an important finding is, yes, you could. and you would get kind of reliability above 90% with the combination. So like you basically send the beacon on all of these events, you just take the first one that occurs. Like this is the idea. But the thing is, if you're using the before unload or unload event hooks, then you can't use the backward-forward cache. And that means you're actually changing the behavior of the website that you are tracking, which is also something you want to avoid. So you need to understand this. And this is kind of the detour or the example to just explain it's maybe rather easy to understand that you have a completeness problem. But to solve it, you have to understand a lot. You have to understand for which particular beacon you have that problem, what implementation strategies there are, what the differences are, and also what the implications of using one of those implementations is. So you can't just try them out. You need to actually do a lot of research before doing this to make sure that you solve the problem without introducing a new one. Again, this was just the completeness part. So let's put a checkmark after this one and say, okay, we've got complete data, or at least we've got a good look on whether we are complete. Let's look at consistency. And the question of consistency is basically, is the data coming in a valid format, and does it comply with business semantics? And as an example, let's look at the different browser values here. So you may note here that it's Edge, which is a choice you can make, but it's not invalid per se. But the thing is, if you click on a website, it's very uncommon that you use Firefox, and it's even more uncommon to use Firefox and then suddenly switch to Edge without switching the session. You know, this typically is not possible. So if this is what your tracking data tells you, then you need to do something about this. You know, it's expected that the browser remains kind of the same when you're surfing the web. So in cases like this, you need to decide what you do. And one idea would be, okay, most of the page loads have been reported as Firefox, so let's just assume that was Firefox as well. You could also say, okay, but the last value that we saw was Edge, and typically the latest value is the best one. So maybe we should take Edge for the Firefox page loads. And you could also say, okay, this is super strange. I think I set the browser to null because I really have no idea what's going on. This would also be a choice, but you need to make the choice because your data is inconsistent and you know that there is something wonky. And what you do also depends on the process in which your data is created and your understanding of the domain. So resolving consistency issues is also not trivial. And there's another consistency issue in this example here, because the LCP value is reported in all kinds of ways. So like we have a string that says 670 milliseconds, we have a huge integer timer, perhaps milliseconds, whatever, and then we have this decimal numbers there that probably represent seconds. So what we would do here would be to normalize everything so that we have the same format for all the timers. For example, at backend, we typically use integer millisecond counters. Okay, and this is the consistency, but these values are not necessarily accurate only because they are consistent. And accuracy basically means that data items represent their corresponding real-world entities well, and that means that the data kind of makes sense. And in the example of this timer there that you see, okay, think about it. You have 690,000 milliseconds, which would be something like 11.5 minutes of a page load. Like I have a Samsung S5, and even I don't get near that. And I think it's technically impossible to like have a LCP over 10 minutes. So what we know is this might be a millisecond counter, but there's no way that this was the actual page load time. So it's definitely not accurate. This does not represent an actual page load time that happened on your website. And if you know this here is an outlier and some kind of bug, whatever happened here, it's not the page load time, then you may want to just embrace the fact that the data is not reasonable, so you can just remove it, for example. And this makes sense because let's say you try to compute some kind of aggregate or average or whatever on your data, it really doesn't help if you have these crazy outliers in there. Again, as the last dimension of data quality, I'd like to discuss a problem that is particularly relevant if you're doing something like business analyses, which is uniqueness. Because uniqueness says, okay, I don't have any duplicates here. And this can be very important to make sure that you don't count, for example, conversions twice. So as an example, consider this timeline here as the user activity over one entire day. So you are surfing on some shop website in the morning when you're drinking your coffee, then you leave for work. And in the lunch break, you browse on the red shoes and then on blue shoes, and then you think, well, nice shoes, let's buy those shoes. Then you go to the checkout and buy the shoes, and then maybe you just shut down your mobile phone, shut down the notebook, whatever. You stop surfing, and in the evening you open the device again and keep on surfing. And perhaps the checkout information, like some kind of beacon or info on you being in the checkout for this product, is just being sent again. What you need to understand here when you're analyzing the data is that the first checkout info was on the actual checkout and the other was not relevant. It was not an actual checkout. You were just there by chance. It's kind of a duplicate. And in case of our example, this could mean that this beacon here at the bottom was just like leftover data from the surfing session during your lunch break. So you may want to just remove the record, like delete it, or perhaps if there's info that you could use, merge all the info in the other data record. But it's important to find out and understand that these are not two different page loads or two different conversions. It's just one thing, and you saw a duplicate, so remove it for analysis. Now, we talked about what the problems are. And it's kind of the question when you're trying to build a system that makes sure that you respect all those data quality dimensions. You need some kind of mechanism to make sure that they are respected. So constraints are basically the rules or conditions, something like limits that you can define that your data must adhere to. Whoops. And yeah. So a simple version of a constraint would be something like a value range, or maybe something like a format for string values that you can have in your data. Maybe also something like a JSON schema when you have something like JSON in your tracking. But it could also be more complex. So for example, you can have something like cross-record relationships that you define in your semantics, like the rule that in the same session, you always have the same browser. This would be something like a complex condition which relates to multiple attributes and also multiple records. Or when you're a database person, something like referential integrity. So the rule that you can never point to records in your database that do not exist. This is also some kind of a complex condition and an integrity or data quality constraint. And you can basically think about anything in your domain. It could be something very custom, but it's important that you can encapsulate the rule into some kind of constraint that you can write into code. And doing this can look something like this. So there are, for Python, I like to use Python for the slide examples because it's rather short typically. There are various frameworks that allow you defining such a schema. So here we have a schema for the example table that we saw. We have the timestamp field, which is just a datetime object. We have the page load ID, which is an 8-character string. We have the browser, which needs to be either of Chrome, Edge, or Firefox in our example. And then the LCP column, which is an integer between 0 and 600,000, so like 0 to 10 minutes, but for example, not negative. And also we have the session ID, which is just an integer here. And if we have data coming into our system, it could be either good or bad. So just as an example, let's have a good data record here and a bad data record there. And it's bad because the timer value there is out of range. So it's this 11-minute load time we had earlier. And then you can write code that actually validates your data. So it makes sure that, for all the records here, try to do the validation of the provided schema, and then either print that everything was okay, or if you have an exception, let it blow up in your face and then give you the reason why. And for our example data, this would look something like this. The first record would pass, and the second would actually cause an exception, and there you see in red the name of the problematic attribute is the LCP, and the failure case at the bottom is the value. So you can define constraints that make your data quality rules, like enforce them and tell you when they are violated and why. Now, this is the basic idea, and this should just illustrate that you can write this into code, but the problem when you're actually doing this in production is typically you have so much data that you can't really do this with Python on your notebook. You rather need to do this in kind of a scalable way. And to illustrate the scale of the problem, at backend, there is like a data error dashboard, and that tells you how many data error problems, like violations, there were. And in April this year, we had almost 500 million data errors, like page loads with some kind of tracking problem, which is a lot. It's 500 million data points that you need to analyze. And what you see there also is we don't have that many types. We have 2/3 of them as aggregation error, and this is already very problematic kind of thing, because it means that there is some step in the aggregation that is waiting for data, and typically it is not arriving. So if you have this kind of problem, it means it takes up space in your aggregation pipeline and blocks until we see something or until something times out. And you also see that there are like 1/3 of the problems related to attributes, which means, for example, you have like negative performance timers or something like that. So this is just the error type, but the different causes, like the specific problems, are quite diverse. So the biggest problem is missing values, so we just don't get some kind of data item we expect. But then there are also different forms of this should be no value, but we get a white space or something like that. And then at the top, you can't even read what it says because we have so many small errors there that happen for one reason or another. And to capture and to analyze and to optimize in this problem space is very complex and requires you to automate basically everything. And the core problem here is complexity. So it's not only that we have many records, it's also that the schema typically isn't as simple as the example. So here you see we have like 6 attributes. At backend, I think we have 150 plus in the tracking data table. So this is very complex to manage because you have to have constraints for all the different attributes, even when they are changing. And then I mentioned earlier that for the different use cases in your analytics process, you have to have different storage systems. So for example, we store the raw data in some kind of data warehouse that is good for debugging, but we have a separate storage system for the dashboarding. And that means you have actual derived schemas, and they are not the same as the raw storage. So you don't just have the raw data table here at the bottom. You have also derived storages here at the top. And for both of them, you need to track changes in the schema to actually update the constraints. And then you also have a plethora of other systems that you integrate. So for example, we don't just use the tracking data, we also use maybe information from the Crocs performance report, like from HTTP archive from HubSpot, whatever. You take data from there, put it into your system, and you need to make sure that all the information is still kind of making sense when you put it together. And you also don't just have the raw storage for debugging and the aggregate storage for dashboarding. You also have specific tables and views for the salespeople, for the marketing people, for customers who want to check out their tracking data with the data, like with the backend stuff, basically. And this means it's all super complex, and you need to find ways to automate this. Then, when you're computing aggregate metrics, for example, counts, the naive way would be to just compute them from scratch, let's say every day, And if you have something like a count, this is rather easy to transform into some kind of iterative procedure, that you have, for example, the count for 1 hour and then for the next hour and then for the next hour. But if you have something like rates, like bounce rates, it's not trivial to make this incrementally. And if you have maybe histograms, performance, load time distributions, and so on. It's not trivial how you can do this incrementally, but it's infeasible to just recompute everything from scratch all the time. So you need to find ways to convert your naive batch-based dashboard that you are likely to start with to a incremental one. And again, at 5 p.m., Felix will tell you all about it, how we did that at backend. Yeah, so this is the continuity as a challenge because data is coming in all the time and you need to produce output all the time. Another problem is volatility because data is coming in all the time, but it's coming in especially during the day and during the night not so much. So you have like variations by time, and sometimes you have peaks and you don't know why, it just spike traffic, and then you need to take more data than you would normally at that time. And also you may have customers in the EU or in the US, so you have like this high time during the day, but the day or the high time, like the peak traffic times, may be varying by customer. And this means you need to have some kind of elastic system so that you have efficient, basically cost-efficient system all the time, and you also need to be multi-tenant in the way that your system can actually cope with one customer having a peak right now and the other customer having no peak right now. And if you combine continuity and volatility, this is actually especially problematic, and I think there should be a word for this. I think there is no word, so I made one up. I call it continuity, which just transports the fact that continuity and volatility at the same time is just very bad. And here is an example. I don't know whether you can see it well, but this is kind of a data viz problem. I may speak with Sophie about this. What you should be seeing here is basically this is a chart of the data errors per hour by customer for 3 customers. And you see there's like this red line at the bottom with a few thousand data errors per hour, super chill customer, everything normal. Then we have the blue one, which is also kind of okayish, but there are spikes sometimes. And then we have this yellow customer there, which goes from, I don't know, like 100K to 500,000 errors per hour just out of nothing. You know, this just happened. And this happened because somebody deployed something that gives us tracking data that is broken. And now imagine your data pipeline validating everything, and the computation time and the storage, like the heap, the memory that you need to validate the data goes up by a factor of 5 or 10 or 20 or whatever from like now to the next minute. Then your processing pipeline may actually grind to a halt, which is a problem for all customers. And it was just caused by a single customer who deployed something. You need to find out what's the problem. You know, you have to have this attribution ability that you can find out where the problem is, and then you need to find the person who can fix it, because if you didn't deploy it, why should you be able to fix the problem? Then you need to decide, okay, can we just disable validation for this customer? Does it make sense? Can we fix the problem? Because this actually can impact availability, because you only have the chance to either fix validation or disable validation, and this can't really be done because then your data quality goes down. You know, so this is kind of a real DevOps challenge, and another reason why I need to really have an eye on data quality and the different problems that can come from it. And these are basically the challenges. So as an outlook, what you need to understand and maybe want to take a look into if you're interested in this topic is find ways to infer constraints automatically to optimize the process of creating constraints and putting them into your production code and be able to adapt with new schemas or schema changes. Then you need to do everything incrementally. So this is at backend basically a rule. We don't do batch-based stuff. It needs to be continuous, which is kind of complex, but it's the only way if you want low latency and scale all the time. There are different tools and frameworks, and you can take a look at them. But I think in many cases, if you really have big data, you will end up building something yourself, or at least extending tools that are out there. Yeah, and then in general, you will have to cope with challenges like how can you distribute the load of your validation? For example, do you shard the load by customer? And if you do that, how do you cope with some customers being 10x the traffic of other customers? Can you perhaps increase efficiency by doing some computations approximately and not exactly? Maybe if you have issues like sudden load spikes because somebody deployed something with invalid tracking data, can you maybe implement load shedding? Can you detect these anomalies in the first place, or do you just notice that everything grinds to a halt and you have no idea why? This is kind of the challenge that you are facing here. Okay, and that's the wrap up. So data quality is important. You can measure it along different dimensions. We talked about completeness, consistency, accuracy, and uniqueness here, but there are more. So for example, timeliness would be one that you could take into the set if you want. Constraints are basically rules, ways to implement or specify your expectations about the data, and especially rules that you can enforce, for example, via code. And validation is the process of enforcing data quality. So basically making sure that the data is good enough for your analysis or modeling, decision making, whatever you do with that. And when you do that at scale, there are various challenges, especially revolving around complexity. For example, because you have big schemas or complex schemas about volatility, data varies by day, by night, by season, by whatever. And also continuity, because stuff is happening all the time and you need to do everything continuously. Yeah, and that's it. So thanks for listening. If you have any questions, I'd be available now or also later. Thanks.